Okay, acceleration. Last lesson we connected, that's okay, equations and motion, right? Equations and motion. So we said, x, we call that displacement. We said if you differentiate once with respect to time, okay, you get x dot, and that gives you velocity, right? So then if you differentiate again, we sort of just teased at the idea that you'll get x double dot, which is acceleration. But that leads to some problems, okay? Particularly with the way we speak. So this is kind of the difference between maths and the whole theoretical, the world we've invented, okay? And what the real world actually behaves like and how we talk about it, okay? So for instance, when we use the word acceleration, right, what do we usually mean? Like if you come with like a synonym, like a phrase, what does accelerate, let's got that right? Yeah. What does accelerate mean? What a troll. Okay, so physics man over there gives a definition to do with forces and mass, okay? I think most of us would say you're accelerating if you're going faster, right? Usually, accelerate means go faster. Hi, Vanessa. Or increase in speed, right? Increase in speed. So for instance, if I'm going at 60 k's an hour, okay, and I'm level at 60 k's, and I'm not changing that speed, I'm not going any faster than that, I would say I'm not accelerating, okay? Now what's the opposite of accelerating? Decelerating, right? Decelerating. Okay? So what does decelerate mean? It means you're still going in the same direction, right? But you're going slower. In other words, your speed is decreasing. Okay? Now, I want you to take this language and have a think about Joe's Mandarin. Okay? Joe's Mandarin. Do you remember, if you graph displacement against time, okay, it looks something like this. So how would you describe the movement of the Mandarin in terms of these words? Right? What's it doing from here to here? How would you describe it? Maybe I should ask this. How fast is it going up here, like at the top? It's not moving, right? It has no velocity, right? Over here, it has some velocity, whatever it is, okay? So you're going from some velocity to none. So what's it doing? We would say the Mandarin is decelerating, okay? Then it gets to this point, and then what? It starts to accelerate, right? Until it goes back to my hand, okay? So we'd say decelerate and accelerate. That's what normal language is, okay? But if you come back to what equations we had, okay? Now, see if you can help me remember. I think we said that x was equal to minus 3 on 49 t minus 14? Something like that, right? Doesn't really matter. Okay, now, you can see, right, if we differentiate this once to get to velocity, okay, what are you going to get? Well, you're going to have a, I'm just going to forget about the coefficients for a second, okay? You got a t squared and a t, okay? So you're going to get something like 2t minus 1. Plus, wait, sorry, minus plus. Is that right? Yeah, does that make sense? Because this is negative and that was positive, okay? And there will be some coefficient out the front, okay? Then you differentiate again to get to x double dot, right? Now, without knowing any of the numbers, what kind of function is x double dot going to be? It's going to be constant, right? In fact, you can see it's going to be 2 times. It'd be like, actually, I'm just going to ignore it. Some constant number, and it'll be negative. Okay. Now, it might not be minus 2. It'll be some different value, but it's still going to be negative. Now, what does that mean? Okay. Over here, it's constant and it's negative. Constant and negative. Now this actually makes sense because usually we associate second derivative, which is x double dot, with what geometric feature? Think back to year 11. This is concavity, right? In other words, we're saying it's always concave down, okay? But therefore, when you talk about accelerating and decelerating, the language starts to break down, okay? Because when you look at this versus this, can you see that these are to do with, do you remember we gave it a name when there's a quantity and it's just a number? Has nothing to do with direction. Do you remember what that was called? It was called a scalar, right? But what we're dealing with, displacement and velocity acceleration, all of these equations, they're not scalar. They are vector. They include direction, right? Okay, so here's what you need to have in like big red letters, okay? Don't never, ever, never, ever. Never, 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 never. Never. Getting back together. Never write decelerating, okay? Please. Never, don't do it, okay? Here's why. Decelerating, right, and the idea of something slowing down, okay? It's valuable, but it doesn't connect it all to the equations that you're working with, okay? Here's what you should say. What we mean when we're like going faster, or those kinds of things, right? A better way to talk about is acceleration with regard to its sign, okay? So positive acceleration and negative acceleration. Okay? Now the positive and the negative don't refer to whether you're getting faster or whether you're getting slower. They refer to which way the acceleration is. Okay? So here, the acceleration is always downward. And that corresponds to a force that we're all very familiar with. We're interacting with it right now, namely gravity. Okay? It's downward and it's constant. Okay? So this really should be, you know, like minus 10 meters per second. Okay? So positive acceleration is up. It might slow you down. Does that make sense? Positive acceleration is up and it will slow you down if you're coming downwards, okay? And acceleration is going against the way you're going. Does that make sense? So if I turn this graph upside down, okay, I can say this in two ways. It's concave up, so that means it's accelerating upwards. Okay? But from here to here, I'm slowing down, right? Even though I've got positive acceleration, okay? So the key I want to get into your head is positive and negative are about the direction of the force, if you want to use physics language, or just say the direction of the acceleration, okay? Now, that's just the key idea to get. As a minor issue, because we're talking here about displacement, which is like, say, a distance or a length, that might be meters. We can talk about velocity, right? That's length over time. So therefore it might be, say, meters per second, okay? Now because it's meters per second and per means division, you'll often see that written as meters second minus 1. Because when you raise something to the power of minus 1, you're putting it on the bottom, okay? In exactly the same way, acceleration is this divided by time again, right? That's what differentiating does, again. So this is either meters per second, okay? Because it's about speed per second changing, or you might see that as meters per second to the minus 2. They're all the same. And you can use any of them when you're in your actual notation, okay?